Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, I'm going to continue with exploratory data analysis, and I'll show you how you can interpret a histogram, which I explained to you in the previous video. So let's begin. We saw earlier that a histogram contains these four properties with which you can interpret it and you can find meaning out of it. And those are shape, center, spread, and outliers. And now with examples, I'm going to show you what these properties actually mean and what they can do in order for you to understand a histogram better. So let's begin with the first one, shape. When describing the shape of a histogram or the shape of a distribution, we should consider two things. The first thing is symmetry or skewness of the distribution. And the second thing is peakedness or modality, which is the number of peaks or modes that the distribution has. And mode is just measure of central tendency, which you must have studied in school. Although I'm going to talk about that in the next video, I would still be using that term over here. And as we proceed, you'll understand it better. So take a look at this graph. This graph that you see here is a symmetric graph. This is a histogram once again, and you can see it is symmetric. It is symmetric because if you look at it, it forms a shape that that if you draw a line right in the middle, then the left and right parts will be completely equal to each other. Right now, I'm just going to show you different types of shapes. Later, when I've explained to you all four measures of interpreting a graph, then we will go through an example of a real graph made out of real data, and we will interpret it and find meaning through it. So now this is a symmetric graph. You can also see that it is single peaked, which means if you look at the graph, there is only one peak that it has. So if you consider this histogram as a mountain, then it is having just one peak, and you would say that it's just one mountain. So this is a single peaked distribution, and it is also unimodal. The meaning of unimodal is it has only one mode. Now, mode is the most frequently occurring value in a data set. So in our case, in this histogram, the most frequently occurring value is the one that you see right on the top, which is the peak. And there's only one peak, so that means there is only one mode. So this is a unimodal histogram, and it is symmetric. Next, you can see here, this histogram is also symmetric because if I draw a line right in the middle, then the left side and the right side will be symmetric, will match. But it is double peaked, which means it has two modes. It is bimodal because you can see there are two peaks instead of just one. There are two. You can say that there are two mountains, not just one, because I can see two peaks over there on top. So this is another shape of a histogram. And once again, I will tell you what these shapes mean when we see an example. Now, another type can be a symmetric histogram, because once again, if I draw a line in the middle, it's going to be same left and right. But this is also uniform, because you can see that all the bars which you can see here are not very small or not very bigger than the other bars. They are almost uniform. So this is a uniform symmetric distribution. Then you can also have a shape which is skewed in one direction, which means it is flat in one direction. And you can see this one is flat on the right-hand side. So this is a skewed right distribution, where it is pretty much high on the left side, but very much flat on the right-hand side. So this is a skewed right distribution of a histogram. You can also have a skewed left distribution of a histogram. And you can see here that this histogram is flat on the left side, but it is having a peak on the left, on the right hand side. So this is a skewed left distribution. So this is where I told you, you talk about symmetric, how symmetric it is and how skewed it is. So if a graph is skewed, then it's not going to be symmetric, because as you can see, this graph is not symmetric because it is skewed. So skewed is essentially the opposite of symmetric when we are talking about histograms. So that's what, and we also talked about peak. So there are three things to remember: the how symmetric the histogram is when you're looking at the shape, um, how skewed it is, and another thing you need to remember is how many peaks it has. Is it unimodal? Is it bimodal or multimodal? Sometimes it can have several modes, not just two. It can have more than two. So that is what the shape of a histogram tells you. Now let's take a look at the center of the histogram. So the center of the distribution is its midpoint. It is the value that divides the distribution so that approximately half the observations take smaller values and approximately half the observations take larger values. Let's take a look at this histogram. In this histogram, you can say that the midpoint is 70, because when I'm drawing this, when I'm using this as a midpoint, then approximately half the values of the histogram, they are smaller than 70, and approximately half are greater than 70. So this is known as the center of a histogram. Next, we are going to see the spread of a histogram. So the spread of a histogram is also known as the variability of the distribution, and it can be described by the approximate range covered by the data. And from looking at a histogram, we can approximate the smallest observation, that is the minimum observation, and the largest observation, that's the maximum observation. And so we can identify the approximate range. So in this graph, the approximate minimum value that we have is 45. We are choosing 45 and not 40 because it's a histogram and we always try to pick the midpoint of a given range. So 40 to 50 is a range, and the middle value over there, middle of 40 and 50, is 45. So we are picking 45 as the approximate minimum. And the approximate maximum is going to be between 90 and 100, which is 95. So approximate minimum is 45, approximate maximum is 95. And so the approximate range in between which this data lies is the range 95 to 45. And so you can subtract the two, which is you can do 95 minus 45 and get 50, which is your approximate range of this, or spread of this histogram. So it spreads over this much area of 50. And the fourth thing we have is outliers. Outliers are observations that fall outside the overall pattern. So they do not fit into a histogram like everything else does, but they fall outside of the overall pattern. And you can see an example of an outlier right here. You can see that there is one value. Everything else is all stuck together, going from 0 to 10. But then there is this one little bar that is forming at 15, which is very much further away from the entire population, from the entire sample. So that is what you would call an outlier, which does not necessarily fall into the range where everything else falls. So that's an outlier in this graph. And so those are the four things you would look at if you were seeing a histogram in order to find meaning into it. And now let's take a look at a real histogram and let's try to interpret it. So this is a histogram which has been created for the ages, different ages of actresses who received the Best Actress award in the Oscars. So these actresses received an Oscar for being the Best Actress, and their ages are given on the x-axis, and the count is given on the y-axis. So that means you would have, say, a certain range that maybe actresses aged between 20 to 30. How many of those actresses got an Oscar from 1970 to 2013? So this is the data. And if you would like to take a look at this data, then I have again linked it, and you can take a look at it from the description box. So this is a histogram created out of that data. Now let's take a look at the shape of the histogram. You can say that the distribution is sort of skewed right, because it's definitely not symmetric. If I drew a line right in the middle, it's definitely not going to be same on the left and right. So this is a skewed right histogram. It is flat on the right side, but it is rising on the left side. And we have a concentration of data among the younger ages. Now you can find out some useful information. Earlier, we only saw what the shape shows, but now we can actually conclude some things from it. So for example, you can conclude by seeing the shape that younger actresses are more likely to get this type of a Best Actress Oscar award instead of the older actresses, because you can see from the graph that it is more concentrated on the left side where the ages are less. So this is what the shape shows you. Then you can see the spread. So the data ranges from about 20 to about 80, and this can be found out from the x-axis right here. So if you subtract the max from the min, that means 80 minus 20, you get 60. So this is the spread. So that means there's a difference of about 60 different ages, but there's a difference of 60 between the youngest and the oldest actress getting an Oscar award for being a Best Actress. So this is another thing you can say from the graph. And then about outliers. So in this case, you can say that there are possibly two outliers which are far away, and those are right here, which are far away. You can see them right here. So those two are the ages which are outliers. So commonly, these actresses of this age would not be getting an Oscar, but these have got. So this is one such thing. And then there are some who are also about 62 years old, so possibly three around 62. And those also you can call outliers. This is what you can understand from the shape of a histogram, and I showed it to you with some real data and real histogram created out of that data. And I hope you understood everything I explained here. In the next video, we'll continue with this introduction to statistics and what it means in data analysis and visualization. So I'll see you there, and thank you for watching.